This is Jeff Mucci, RCR Wireless News. We're in Palo Alto today meeting with Art Rydell, who is CEO of Centera Corporation. Art, thanks for joining us today.
My pleasure, Jeff.
This is a first for me, a programmable analog signal processing platform. What does that mean?
Okay. The world has really gotten used to using digital signal processing to handle many of the communications problems that we have. There's a problem with digital signal processing, though, which is first, that it consumes an awful lot of power. Secondly, that the solutions take a lot of space.
Right.
And third, that you just can't use it at all above some frequency in the several hundred megahertz range. Mm-hmm. There's a big problem in the wireless infrastructure today, which is that we're trying to do things all the way up to 3.5 gigahertz and beyond. We just plain can't use DSP. Also, we're already doing this in 3G, but particularly with the advent of LTE, we're really pushing towards much, much smaller, much lower power radio modules in much larger numbers, which, of course, requires them to be much lower cost. And many of the architectural workarounds that we used to use in 3G to be able to do certain processing at baseband, to avoid the need to do it at the higher carrier frequencies, just doesn't fit in these LTE architectures. Mm-hmm. As a result of which, the world needs to start doing much of that signal processing at those higher frequencies for much lower cost, much more efficiently, and in a much smaller form factor. That really requires you to take the processing back to the analog continuous time domain out of the digital sample data domain. But nobody wants to give up the programmability that they got used to with DSP.
Right.
So we allow them to do both. We allow them to take this signal processing, move it back in the analog continuous time domain to save the power, do it at the higher frequencies, but at the same time, we preserve most of the programmability that people got used to with DSP. And the reason you've never heard about it before is, I think, two reasons. First, the world didn't really need it more than a handful of years ago. And secondly, candidly, as of a few years ago, nobody believed that we could make it work. So, but we have, and we're delivering it now to a number of customers worldwide who are beginning to deliver it to their customers. But that's why you've never heard of us before.
So, describe for me the form factor of your chips that are being shipped compared to the traditional 3G chipset that's embedded in base stations.
Okay. We have a family of parts coming out over time, but the part that we're shipping, right now is focused on a function called power amplifier linearization that allows power amplifiers to operate much more efficiently than they can if they don't have linearization help. Mm-hmm. Historically, that was performed at baseband using digital signal processing. It typically requires, 100 square inches or so of board area. That's probably a reasonable approximation. A board full of very high-end FPGAs from Xilinx or Altera, whoever, A to D converters and D to A converters from the high end of the TI or ADI or whoever, catalog, et cetera. The target architecture for these low-power LTE radios going into the microcells, picocells, and active antennas, on the other hand, for the whole radio, not just the power amplifier, not just the linearization function, is probably about the form factor, is a pretty good approximation of the stack of business cards. So that's a big shrink. So what our part does for this particular function, which is one of the several functions that has to be integrated and shrunk down, for this particular function, we take this and we reduce it to one small CMOS part.
Interesting. And you mentioned a suite of products that either you have or are going to have.
Yes.
Can you talk a little bit more about that suite of products?
Yes. So later on this year, to the linearization functions in our part, we're going to be adding a series of ancillary functions, power monitoring, bias control, and so forth, which are very easy for us to perform, sitting where we do in the signal chain with capabilities that we have, and save several currently external parts to help the customer further reduce the BOM. But then later on next year, and we're not really talking about the details yet, but we have what we think are some pretty exciting plans to integrate much more of what was currently on one of those little radio cards into our single chip.
Interesting. One of the things we like to talk about at RCR is humanizing technology. There's a lot of what you just talked about that many of our readers, and maybe myself included, don't fully understand.
Yes.
Can you talk about the how your product is going to change the way users use their devices or products?
Yeah. Well, for the grace of God, go all the other carriers, after AT&T, right? So they've had the blessing or curse of, doubling their broadband, data traffic roughly over everybody else because they got the iPhone first. Well, everybody else is going to be there real soon, whether it's with iPhones or something, equivalent.
Sure.
And all the projections, your publications and everybody else's are for, data rates just to keep doing, that. So all the operators are scrambling, committing massive amounts of CapEx to building out their networks to support that. There are several problems they have, backhaul and so forth, but one of the problems they have is with the limited amount of spectrum available to them, increasing data rate and coverage over the air.
Right.
To do that, cost effectively requires a big change in the radio architectures that have been traditionally used. Right now, you drive around, actually, Korea and Japan are ahead of us in this evolution, but you drive around here or Western Europe, and there are a lot of big cell towers scattered around. That's basically what you have, and you have to shift to much more distributed so-called heterogeneous networks to do that. Lots of microcells, picocells, active antennas, and so forth, and that really drives this shift in radio architecture. So the human face of it is, if this whole technology trend culminates successfully, people will get what they want, and the carriers won't have a whole lot of unhappy customers. The operators won't have a whole lot of unhappy customers. If this technology evolution were to stall out for some reason, everybody's going to be in the same place then that AT&T is now, which is with the amount of CapEx they can conceivably afford to deploy, they won't be able to satisfy demand, provide the required coverage, and they'll have a lot of unhappy customers.
So what is happening differently in Korea and Japan that's not happening here? You mentioned they were further ahead of us. What did they do differently?
Korea and Japan, for whatever reason, you travel over there, coverage is ubiquitous. You can, go into the inner bowels of a big building, you can, drive through a tunnel, you can go wherever you want, and broadband coverage is ubiquitous. And, they leaned on several approaches to do that, but it wasn't just by building more big, cell towers. So what they did was they put microcells inside some of these buildings. What they did is wherever they found a hole in coverage outdoors, they would drop a little RF repeater in there, a little low-power RF repeater. They would just slap it on the side of a building or whatever they could find. So it's not as pretty as what you see in the LTE specs and so forth, but on an ad hoc basis, they evolved towards an architecture that was really an early implementation of one of these so-called head nets or heterogeneous network architectures. Well, in the U.S., we have more wide open, spaces, and for whatever reasons, the operators were a little less aggressive about some of these approaches. So we have what we have.
Interesting. 5 years ago, in the past 4 to 5 years, not many companies, semiconductor companies, were getting funding.
Yeah.
Why were you funded in the area that you were funded? What sets you apart?
We love that question. Thank you for asking it. It's become very hard to make money in the traditional, digital system-on-chip kind of semiconductor companies that, sell a device that, gets deployed in 1 million TV sets worldwide or something.
Right.
But we're a different kind of, animal. So first, we sell on the infrastructure side, not on the consumer device side. And the unit volumes are somewhat lower, but the interesting thing about the infrastructure side is people will actually still pay a price for value for solutions that you deliver. So our margins are significantly better. Secondly, as you indicated in your introductory comment, we combine the complexion of an analog semiconductor company and a programmable semiconductor company. as opposed to, again, a traditional, digital SoC, fixed function, kind of company. In the time that we have, of course, we probably shouldn't go too far in the details, but I think all your readers will relate to the fact that the analog companies, the ADIs, the TIs, the Linears of the world, and the programmable chip companies like the Xilinx and Alterras enjoy much better operating margins and are much more capital efficient than the digital SoC kinds of companies. So we combine a lot of those attributes. And you put that together with the fact that, false modesty aside, we think what we're doing represents a pretty fundamental technology breakthrough with very important market applications in wireless infrastructure and beyond. And we're pleased and proud that our investors saw this as a significant opportunity to actually build a significant semiconductor company.
Who are your investors, and maybe share with me what role they have played in helping you shape the vision of the company?
Okay, I'm pleased to brag about our investors. August Capital, Seven Rosen, Kleiner Perkins, Caulfield and Byers, and Ridgewood Capital are our principal investors. The first and foremost thing that those guys did was to get it and understand the vision and the importance of what we're doing. Early on, where candidly, as recently as a couple of years ago, we still had a lot of people who just flat out didn't believe that we could do this, and other people who didn't get it, that 4G was really going to happen and that 4G was going to drive a fundamental change in radio architecture required and in the kinds of semiconductors that were required to implement them. And, our investors actually did get it. Mm-hmm. That's, I'd say, first and foremost. The second is that the company actually was originally funded all the way back in 2002. I joined the company at the beginning of 2006, right. But it was funded all the way back at the beginning of 2002. Actually, based on this technology, but focusing on very different applications, not in the wireless infrastructure. And we realized shortly after I joined the company that we had a much better future if we refocused on the wireless infrastructure, which meant an entirely new product family and so on and so forth. Those, as you know, were fairly tough times. Sure. And our investors one more time had the courage of their convictions to say, nope, we're going to go for it and support the company through this transition. So that was another time where they really were there for us. Beyond that, there are a lot of fairly traditional things that many venture investors say they will do, but I think our guys have gone through this on. They're pretty well connected, with our customers. Right. They're a great resource in terms of when we're down in the forest, chopping down trees. They'll remember that they're up there above the forest. We'll occasionally tap us on the shoulder and say, hey, you might be running out of trees over here. Do you think you should consider turning over there? So they've been a great resource for us across the board.
That's great. All right, thank you for your time today.
Oh, it's my pleasure, Jeff.